What else does MVHR system do? The mechanical ventilation heat recovery. What else does it do? Well, an MVHR will record all the humidity levels and flow rates. It will store that in its little brain in the chip, and every now and again, every 12 to 14 months, that could be tested by it plugs it into a computer with a particular program for that machine. And what that does is that works out what this has done all over the year, or the volumes and the temperatures and humidity, inside and out. And what it does is it stores it, and it'll work out the efficiency of the machine, how efficient it's been. And also from that, you can work out how much has cost to heat that house. An average house in passive house probably costs about £70 a year to heat. So, but that's just an estimate. Some of them are less, some of them are more. It depends on the design. But we know these things because the MVHR stores the information, and we can work out the efficiency and the costs from that.
Brilliant. Okay, John. I just thought it was worth just touching. You do mention the VOCs and how that affects health, volatile organic compounds.
Yes. VOCs. VOCs, volatile organic compounds. Now, this comes from general living. It comes from our carpets, curtains, our soft fabrics. Every time we use a spray to clean something or everything else, these are all things that put in the air and float around. So these are particularly in an airtight build, potentially quite a health problem if you are susceptible to lung conditions like asthma or something like that. So this is one of the things that can be controlled and monitored by the MVHR. Excuse me.
You better just keep going.
So this is one of the things that's able to be controlled by the MVHR system and monitored. So that's VOCs.
Yeah, excellent. And there has been some research, actually, in some articles that we might go on to discuss a little bit more, but they've shown that cooking can really affect your health. So the extract and such like are really important.
Cookers, when cooking, we produce lots of steam. Not only do we produce steam, but potentially there are other things as well. When you cook a solid food within an oven, that's producing some form of contaminants to itself, which in itself isn't harmful, except for when you live in a airtight box. So things like extractors above your cooker are actually quite important to take out all the grease and the cooking and that type of thing out of it before it goes through the heat exchanger.
Yeah. So one of the things I just thought were worth touching on was your personal experience. I know we have talked about it before, but just how valuable MVHR is, and I found this in my own research as well through people actually coming to visit the homes that we developed. I had a lot of feedback from people that once you live in a house with an MVHR, if you have any breathing related issues, it really is like a lifesaver, and they never want to live in a house without one again.
That's true. Many times I've seen families, including some of my own family, with lung conditions, chronic lung conditions, not just asthma, but cystic fibrosis and other lung conditions. And I've seen many families around the UK and how they respond with an MVHR system and a sealed house. And it's always positive. It's always positive. The environment isn't just filtered to get the pollens and the dust and everything out. It's also consistent. It's a consistent humidity. It's a consistent temperature. It's a consistent air volume within the house or pressure. So therefore, your body can get used to this. And if you have a particular lung condition, it really can be very beneficial to your health. Seen it many times.
Yeah, I just wanted to touch as well, John, on the fact that you're talking about a difference in terms of efficiency. So what does that mean? If something's 40% efficient versus something 90% efficient, does that mean if it's 90%, it uses the heat better, and if it's 40%, it use it less? Is that
Yes, basically efficiency of the the efficiency of an MVHR system or the heat exchanger, the heat recovery. The unit itself is called a heat exchanger for heat recovery, because it exchanges heat at different rates. So different designs will take a greater amount of heat or a greater amount of exchange over the same amount of time. The reason for that is because you don't always want a high efficiency unit. You may only want to, so if you're in a higher population area, you may produce more heat within that environment. You do not want to take too much of that heat. You may actually want to just balance that out. So you use something with less efficiency. So therefore, you're keeping a constant rate. When it comes to something where you may need more efficiency, where it's going to be more difficult to keep it warm, then you need a higher efficiency, which is where a cellular filter or correction, a cellular unit heat exchanger would be used to get that maximum efficiency. So the efficiency of the unit will be designed purposely for that particular project.
that's interesting. So, if, for example, it's 90% efficient, it might be, but that's too efficient, and actually you need to reduce the efficiency.
Absolutely. Efficiency may need to be reduced for a particular project. This will all be worked out in the PHPP and the Passive House Planning package of what you need to achieve your MVHR, your mechanical ventilation heat recovery, is a key part of that. So therefore, you may need to use a lesser efficiency and a lesser efficient unit potentially.
Yeah, so we'll be talking about PHPP in a lot of detail in this course. In fact, it'll be Claire who's discussing that with our students. And actually, this is a really good time to have a clip where Claire is removing one of the filters, and I'll just allow that video to run.
Yeah.
And then you can.
Yeah, there are many types of filters, but that will be the only one we can show within the period of the video.
Yeah, and so you can see from this video here, just how much things get extracted from the air. I was quite surprised by this. I know that air pollution is becoming a bigger talking point, but when you see it, like you've seen it just there.
Absolutely. No, well, when you take the filters out of an MVHR system, that's not until you see it, you realize how much stuff is coming into your house. Doesn't mean to say that you can't open doors and windows. This is one of the myths of passive house. You can't open doors and windows. Fact is, you can live in it the same as any other house. Matter of fact, many passive houses have large doors, patio doors, for outside, inside living. That's fine. It's just when you need it to, you just close everything up and allow the house to do what it's supposed to do and what it's designed to do. But you don't have to live in a passive house in any particular way if you don't want to. There's just a few rules to follow. And that is just to understand how the building and how your living environment works.
Yeah, to maximize the efficiency.
To maximize efficiency.
Keeping the doors closed and such like is useful, but you don't have to.
No.
So one of the things you did touch on it is calculating the volume of air in each room and how helps design the heat, the MVHR system, and I just thought we'd touch on that a little bit.
Yes, when it comes to MVHR design, this is why you need somebody who does this. Go to somebody who's got the correct tools to work out what it is you need. You may have two houses that's got exactly the same square footage. This has got one layout, this has got another layout. You could potentially need different MVHR system designs for those two different houses. Even though the unit itself might be the same, the system to which feeds that may need to differ simply because of layout. This is why it needs to be calculated to individual design. It's very important.
Excellent. And in my own research, I've spoke to a lot of people who've done retrofit, and one of the things that was fed back to me was just how important it is to design your MVHR system first. Step one.
Step one for MVHR is design. If you've got a finalized design you're working to with a retrofit, you already know the walls, where they're going. You already know the connection points. You know the size of rooms. So potentially you want to understand what ventilation you need for that house before you actually start work, because you may need to do additional works to compensate or to house ducting, to route a particular duct to a particular room. So therefore, get your MVHR system designed on a retrofit very early, because it could potentially save you a lot of work later on. Because if you've started the work and you're 3/4 of the way through, then you get your MVHR system design, you may have to redo work. And when it comes to redoing work, it's time consuming and it costs you money. So get the design in early and do the build around that design.
Absolutely.